Today we're going to talk about the general idea of an ORM and the specific example about Sequelize, which is the ORM we're going to use when persisting our data through our RESTful API. Right, so the idea is to ensure persistence of objects in relational databases. It eliminates the need to write SQL code. This has a series of advantages. The first of which being that although the SQL language is somewhat standardized, it's not completely standardized. So you're going to have variations. For example, you're going to have even for trivial matters, you're going to have variations, such as how date is stored. And if you try to work with dates in something like SQL Server and in something like MySQL, you're going to notice that stuff is differently handled. So the language is not really standard. Now that makes SQL code itself relatively more difficult to maintain than my objectual code. Furthermore, my SQL code is going to be written in a different paradigm, which means that I'm going to have to switch between thinking in SQL and thinking in my objectual language. So what I'd rather have is some objects which are entities, which are persistable objects. And I'd rather have a layer of abstraction which will ensure persistence for objects independent of any particular relational database. The second thing is that relational databases think about data in a relatively strange fashion, or in a different fashion. Because if you think about something as simple as a varchar, what is a varchar in an objectual language? Right? What is a string with a limited length? So again, I'd want to handle this in a more uniform manner. Now, Sequelize is an ORM for Node.js. It's like the rest of the frameworks for Node.js. It's going to be event-based and or callback-based. However, we can and will use promises for our code, because like we saw previously, promises bring some advantages to readability and maintainability of our code. Our Sequelize actually supports something more, which is migrations, which is versioning on the data model. However, we're not going to play around with that. What that would handle is the fact that we could add, for example, a column or remove a column. And we'd have an up step for the migration, the one which adds, and the down, which reverses it. Now, this is not as useful as it seems. It is reasonably useful when we are developing a new application. However, we must remember that relational databases are focused on consistency. And if I add a column, the structure might be consistent, but the data probably won't be. So let's start looking at some examples, and then we'll come back to this. So the first example is going to be something which allows us to connect to our database. Right? So let's do this. I can see that I've gained access to the Sequelize library for require. It's written with a capital S because what it exposes is a constructor, and our convention about constructors was that we were writing them with capital letters. And based on this, we're going to get an object which is also going to contain a connection. And what we have to specify is the database, the user, the password, and then a series of options. And in this case, one of my options is going to be that the dialect, the particular database, is going to be MySQL. Now, if we look for the dependencies for this, right, we're going to see that the dependencies are Sequelize, of course, because that's what we're using. But the second dependency is going to be something which is called MySQL2. And the reason why I have a second dependency is that Sequelize, the library itself, handles the abstract idea of storing data in a relational database, no matter which database. And I have a separate package for each of the relational databases it supports. The reason for this is to not bundle a lot of useless code, because I'm going to have different connectors for MySQL, for MSSQL, for PostgreSQL. And instead of having them all, I just have them in different packages. This makes sense because usually I'm not going to have an application which stores data in a database, which is going to connect to multiple types of databases. Right? I'm only going to have that if I'm explicitly building an administration tool. Obviously, these were installed with npm. And to get back to our connection example, this is connecting to the database without doing anything else. Right? And it just says Sequelize authenticate, and this returns the promise as any asynchronous operation. and then we're going to have a then branch and a catch branch. The then branch is just going to say we're connected, and the catch branch is not, so just going to log the error. So let's see this working. All right. So if we go to general, we can run this with node check connection. Right, we're connected, and that was it. And I can see that Sequelize actually logs what it's executing here. Now the second step would be to create some entities. I have two ways of going about this. One of them is code first, and one of it is data first. What we're going to explore now is code first, which is we're going to define our models, and then we're going to create our tables automatically. Now, in order to check what's happening, we have to be able to connect to MySQL. The way we're going to be able to connect to MySQL is by the MySQL client, which is going to be used like this, minus user root, minus password, a generic password. Right. And let's just drop the database so we can recreate it. So drop database, Sequelize tests. Let's create a new one. We'll get back to this. So when creating models, I'm going to need models because if I look at an ORM in a classic language, because I have ORMs in every language basically. I'm going to have Hibernate for Java, I'm going to have Entity Framework for C#, I'm going to have SQL Alchemy for Python, etc. That's because on a fundamental level, the idea has a lot of benefits when it comes to code maintainability. Now in a classic language, like I was saying, what I'm going to have is I'm going to have to define some characteristics of the persistent behavior, such as which column I'm going to store a particular attribute in. And in a classic language, I'm going to define those as annotations on the class generally. And this is not a classical language. I don't have an equivalent of the class, which means that I'm going to define some meta objects, which are going to be objects which define how a particular type of object is stored. And this is going to look like this. Right, so here I have two objects, which are author and message. And I see I can create them via Sequelize define. And in the simplest form, the way I'm going to create them is by saying attribute type. So name, Sequelize string, email, Sequelize string. And I notice my definition is a bit sparse, right? It doesn't seem to contain everything I need. And the reason for this is that I have a principle at work which is called convention over configuration, which means that I have a convention at work which is going to allow me to not specify things I don't intentionally want to define. Which means that, for example, if my entity is called author, the table in which it will be stored is going to be called authors, right? So the plural in English. If a particular field is called name, for example, the particular column where it's going to be stored is going to be called name. I can change this behavior by configuring the field. However, if I don't want to change it, I do have a behavior without having to define anything. So let's see what happens if we create our table. Right, so we're just going to say node create tables. And this is apparently going to do something. Some SQL stuff was executed in the background, although I have never written it. And now if we connect to our MySQL and we say use Sequelize test, this is a freshly created database. So we can say show tables. And we're going to see that it has two tables, right, which were created automatically. And if I say describe, for example, authors, I can see what Sequelize did. And I see I have some things which are in addition to what I explicitly defined. So first of all, the column for name was actually name. The column for email was actually email. I can see that Sequelize string in this particular form actually translates to varchar of 255. But some other fields have appeared, such as ID. Now, I actually need ID. The idea of an ORM wouldn't function without having a unique primary key, right? Because if I think about two objects, which are in memory and have the same values for all fields, I can still differentiate via their address. Right? They're allocated in different parts of memory. Well, if I store them in rows in a database, I'm not going to have that. So I need an equivalent, something to ensure unicity. And this is going to be my ID. It's been added automatically. If, however, I elect to define explicitly a primary key, it's going to use what I've defined. And I see I also have some timestamps, right, which are going to remember when a particular row was created and when it was last modified. I can also change this behavior and make it not use timestamps. Now, if I think about if I think about those types, right, because obviously I can specify some types. I can actually access them really easily from the documentation for Sequelize. Right, so if I look in Sequelize, I'm going to have data types, and these are the types. And I have the if I look on the right side, I can have the corresponding type for my particular database. Right, and these are the types in a relational vision, and these are the types that I have defined. For example, if I'd want a varchar of a specific number of characters, I just pass a parameter here. Okay, so this is one sort of model definition. However, if I just have this, I wouldn't have enough granularity, right? For example, I have a field which is a varchar which is called email. Is that going to be valid? Probably not, right? If I let any string value be placed in that field, I'm going to probably get something invalid. Okay, so I can actually define my entities in a more complex fashion. So instead of just using the type here, I can use an object definition, and I can still specify the type in the type attribute. I must specify the type, because otherwise it would be unclear. And I can see that this time I said allow no, false, for example, which means that the name cannot be known. For email, I said type Sequelize string, allow no, false, and I said validate, and I used one of the pre-existent validators, which is Sequelize supports a series of validators out of the box. And I can actually, let me just show you, I can actually use any kind of validator from this list. And I can see that apart from validators such as length or lowercase or stuff like that, I actually have regex validators, which means I can probably implement any validator I want. So this actually will function by extending the functionality that the database provides. We're right now working on MySQL, and for MySQL as a notorious feature, if I use a check constraint on a column, it's not going to have any effect. It exists, but it doesn't do anything. Right. So I can bypass this and add additional validation. Now if I look at message, again, content was Sequelize text, which is going to be something potentially larger than a Sequelize string, than a varchar. And then I have something else, which is the ability to define relations. Right. And this also has many message. This brings us to an interesting point, which is that when I work with these objects, if, for example, I serialize them to JSON, I just pass them as JSON, I have a series of these messages and I pass them as JSON objects, they're going to look like they contain exactly those fields that I saw in the database, and that's it. However, when they're in memory, they're actually complex objects which have a lot of helper methods. And for example, by saying also has many message, I have something like get messages, which was a method which wouldn't have existed regularly, but was added, because they're in JavaScript, it was added dynamically at runtime. Okay, so this is going to work, and if we look at what this does, right, let's just run this. Let's just run this. So we're going to say node create tables v2. It's going to create my tables. Now, interestingly enough, when I say Sequelize sync, what's going to happen is that if the table did not previously exist, it will be created. But if it previously did exist, I'm not going to get any change. And I can bypass this behavior by saying Sequelize sync force through. And this is going to drop my tables before recreating them. And if I now look in my database, right? So I'm going to say show tables, describe authors. Author is going to look the same like as it did before, but messages will actually what? That didn't give me the required thing. Let's do a quick fix. Yeah, messages is going to have a foreign key, right? Which is going to lead to my authors. And this is how I'd expect things to look if I reflect this relation in my database. Now, this is another interesting point, which is that relational databases regard relationships between things differently from objectual languages. Because what I'd say here is that an author contains a list of messages. What I'd get in a relational database is that a message has a foreign key to author. And this is again a difference which is mitigated by using an ORM. Okay, let's go further with this. So we have an order which and we have a client, which are different things. And this time we're going to do something a bit more complex. First of all, I can see that for my Sequelize object, I have now said that timestamps is false. Now I saw that when I'm creating entities via Sequelize, I get some additional fields which I never specified, which are created at and updated at. And by saying timestamp false in the configuration of the Sequelize object, I'm not going to get those fields. So I'm going to get something more intuitive. Now for my order, I've also provided the default value, which means that if I try to insert something and I don't specify a value, although I've not specified the value for a column which doesn't allow null values, it's still going to give me something there, which in this case is going to be false. Booleans are tiny ints, so they're ints which have a value of 0 and or 1. Now for my date, I have a Sequelize date, which is going to have a default value provided by the database, which is going to be Sequelize now, so the current time. For my client, for example, I've used another validator, which is a length validator, and it says the length has to be between 3 and 20. Now something more interesting though, is that I can have virtual properties. What this means is that I might have situations in which I'd want to act in my persistent objects to get the impression that I have properties for stuff which is not stored as such. For example, if I'd want to store the structure of the faculty, right? I'd have faculties which have years, faculties which have specializations, which have years, which have groups. And if I'd have an object in which I say get group name and I get 1077, that would probably not be explicit enough. In any graphical user interface, I'd probably want to say something like group 1077 of the specialization whatever, right? Would be clearer. However, if I store that in my database, I'd actually have redundant data. And I can get around this. Say I have a first name and a last name. I can get around this by having getter and setter methods for properties which do not exist. In this case, full name is going to give me the name and the... Okay, we can do the same thing for a particular property. For example, we'd want the user to supply a particular value and get something else in the database. So in this case, we'd want to have to let them supply the name in the first name in any form, and just store it lowercase. Right, so I can use setters and getters for that. Now, if we look at what we get by running this, it's tables v3, right? We can now look at a client. we're going to see that we no longer have our timestamps, and that our virtual thing, which is full name, doesn't appear anywhere. It's not anywhere. It's not actually stored. Okay, the last thing we want to talk about when talking about entity creation is going to be the fact that we're probably going to want to store models in different modules, right? So in different files, so we can better manage them. And in this case, all right, let me just wrap this. In this case, we're going to store them separately and then use Sequelize import. Now, in order for Sequelize import to work, we're actually going to have a structure which is a bit more bizarre, which is that in the module export for our particular entity, we're going to have a function which is dependent on something containing a connection, which is the Sequelize object, and something containing a series of data types, which is the library itself. Now what we're returning here is the definition for a particular entity. And this is, of course, again going to work. Right, let's just check it out and see what we've obtained. Right, we've got our book. And the advantage is that we can more easily identify everything which is connected to a particular model. Now, let's see if we skipped anything. Now, in order to see the operations we can do on Sequelize, the best way we can go about it is by actually creating an API with persistence. And let's look at our persistent API and just comment about everything and see how we can test it. So this is a simple API, which means that it will concern a singular entity. And in this case, our entity is going to be book. Right, so we have our entity definition, which is in the simplified fashion, which is a book has a title, which is a Sequelize string, so a varchar, and the content, which is a Sequelize text, should our database support this. Now, this is also an Express application. The reason why we need the body parser is because we're going to want to add entities, and adding entities is going to be done via sending a JSON object over the network. So we need that JSON object to be deserialized, and this is going to be handled by our middleware, which is going to be bodyparser.json. Now we've done something which is not necessarily inspired, which is we've exposed an endpoint which recreates our database structure. This is generally a bad idea, but since we're just doing this for demo purposes, it's going to be all right. Obviously, such functionality should be hidden behind some sort of gates, right? We shouldn't be able to run maintenance concerns from a public API. Now, the thing I'm going to do here is synchronize with the database. It's going to be forced through, so it's going to delete the pre-existing entities. And this is going to return a promise. Now we're in an endpoint, so we must send something to the client on each code path. Because if we don't, the only choice the client has is to wait infinitely or until the connection times out for a response. In this case, we're not actually interested in what the promise returns. We're just interested in the fact that it resolves successfully. What will the promise return? Well, it will return probably the number of affected rows, right? Because that's what updates, delete, etc. return on the database level. So we have to do this previously, so previous to doing any other operations. And then we're going to have a series of endpoints representing the actual logic. So let's go through them and see how this would work. So first of all, if I want to get all the books, now getting all the books, I'm going to go to just the get to the books address. And this is going to work like this. I'm going to have a book.findAll. And book.findAll is actually going to, in this form, function like a select star. Now, every one of these Sequelize methods which appear on each meta object, on each model object, so like book, is going to be highly customizable, right? So, for example, here I will be able to specify, I have a key which is going to be called attributes, which will allow me to specify projection, so which of the attributes I'm interested in. Now I also have a key which is called where, which is going to allow me to specify selection, so what condition should the returned rows fulfill. I'm also going to have a key which is called include, which is going to allow me to do joining. Right, this is another interesting discussion, which is relating to the idea of eager loading. So let's say we have some dependent entities, such as a book has chapters. Should I load the chapters from the database every time I load the parent book? What do you think? Would that be a good idea? Would that be a good idea in every case? No, because if we look at the example for our faculty, if we load the faculty itself, we'd actually load, I don't know, 10% of the database, so everything. However, in some situations, I might want to load dependent entities with the parent entity. And in those situations, I'm going to be able to specify the Sequelize is going to allow me to specify that I'm going to eagerly load them, so that they're going to be loaded. And I'm going to do this by using include. So I'm going to say include chapter in this case. Now, find all is going to return something which is interesting, which is a list of results. Now, the results themselves are going to be objects like this one. However, when I'm going to say response status 200 and send it via JSON over the network, what I'm going to get is a lot more similar to what I see in the database. So I'm going to get some simplified objects, which are actually contained. So one of these books actually contains a property which is called data values, which contains the simplified object, which is what I'm expecting to see. Now, the second operation is going to be creating things, right? And creating things is going to go via the post method. And we've elected to make a more complex post logic. So in our case, we're going to allow both posting a single object and posting multiple objects. And if we post a single object, what we're going to get is, what we're going to do is a book.create. Now, this is actually two operations. Because what I can do is just create a potentially persistable object in memory. And this is going to be an operation called build. What this is going to do is check every validator and all that stuff and get me a valid object in memory. The object, though, is disconnected from the database. So it exists in memory, but it does not exist in the database. And in order to persist it, I'm going to use another method, which is going to be called save. However, in my particular case, I'm not interested in these two steps. I want to just get the object from the user and then persist it immediately. And I have something which is going to do both the steps in one method, which is book create. And I can see I'm going to create it from the request body. This has a series of consequences. First of all, request body must contain a valid book. Now, in order for it to contain a valid book, the text that I've received over the network should have been deserialized by something. And that something is going to be, like we saw last time, body parser. Right? Body parser being something which is a middleware. A middleware, again, I remind you, being something which gets to my request before it gets to my endpoint. And then passes control to my endpoint. So when I get to app post on books, I'm actually going to have in request body a valid book. However, what I've elected to do is actually use a query parameter, right? So if I say something like /books bulk equals on, what I'm going to get is this site, this particular branch of code. And I can then use bulk create. And bulk create is going to get an array of whatever entity I'm trying to create and create all of them. This actually reflects something interesting, and it has some application. Because if I add every entity one by one, I'm going to get a series of inserts which are going to be done by separate requests. Right? I'm just going to, if I have in my front end, I have a for each, and I just add each entity. This is going to function like this. I'm going to send each entity via post to the books endpoint, And this one is going to persist them one by one, inserting entity by entity in the database. Now, every bulk operation is going to work on a cursor, right? Or, depending on how it's implemented, in the case of insert, I can actually supply multiple values and just run one single instruction. So this is going to be one request. So it has some performance advantages. Now, I can see that I can get through my ORM, I can actually get some optimizations. And this is going to reflect in another aspect, which is an advantage of an ORM, which is that I can pass some of my responsibility to something else. For example, if I'd actually do manual inserts, I would be responsible for sanitizing user input. Why would I want to sanitize user input? What might the user do? Do you know what SQL injection is? Well, the user has an input at their disposal, and instead of writing their whatever name, they're writing SQL code. And usually I have to sanitize it somehow. I'd have to handle this manually. However, if I use something like Sequelize, I have it handled in a more effective and uniform manner. Right? This might be handled by Sequelize itself, or it might be handled on the database level, depending on the driver. Because on the database level, what I can do is actually use some stored procedures which are going to have validations inside of them, which are going to be generated. Right? So instead of doing my insert as a regular command, I'm going to wrap it into something which actually validates. Right? It doesn't accept arbitrary code. Okay, so bulk create. Now let's stop here and just test our thing and see how we test it. So it's API simple. Now, obviously, we're going to be able to send the GET really simply from the browser. However, this is not going to be sufficient. So we're going to have to use something which is going to allow us to do request crafting. And in our case, we're going to do request crafting via Postman. We're running everything on local, so our requests are going to go to localhost. Let's just delete this. So we're going to say get. First of all, we have to create our tables because we don't have them. So create. Right, so recreated all tables. Now if I check in the database, I see that this is true, that I now have a books table. If I go to books, what I should get is an empty array. Right, I don't yet have any books. However, I can add a book by posting something. If I'm posting something, what I'm going to do is I have to supply a book, and the book is going to be an object in JSON. Right, now, JSON is an object serialization scheme. It's a JavaScript object notation, which means that my serialized objects are going to look really similar to JavaScript objects. In fact, if I take a JSON object and put it in a JavaScript variable, it's going to work. However, JSON has a few more restrictions than JavaScript objects which are just defined in my code. In my case, I'm going to have title, and I can see the key is written as an explicit string, and that for strings, I can only use double quotes, not single quotes. So title, some book, content, some content. Well, content. So this says created, but I might not believe it. So let's get. Right, and I now have something which is not what I was expecting. And the reason for this is that whoever has a resource, and they communicated over HTTP, has to specify the type of that resource. And what I've actually done here, I've sent a post request which has the type text plain. And it's not actually text plain, it's some JSON. Which means I have to add a header, which is going to be content type, application JSON. Right, so this is created. And right now I see that I've managed to add my book in a valid fashion. Now let's test our bulk thing too. And our bulk thing, our bulk insert, is going to look like this. I can no longer send one object, or I can send one object, but I have to send an array of objects. And say we're adding a different book. We have these two, and if I just do the request as is, it's not going to work, right? Because the request is only going to work if I supply a query parameter, and the query parameter is going to be something like this: bulk equals on. Right? So I managed to create multiple objects, and now if I say get, I'm going to see that everything was created successfully. Okay, we have a couple more operations, and our operations are going to be, that is for a single entity, are going to have to cover edit and delete, right? So edit and delete, and maybe I'm going to want to be able to access a particular entity, so a particular book. So in order to access a particular book, our logic is going to look like this. Now, when doing queries on my database, we're going to go back to queries shortly and see how we can make complex ones. But when doing queries on my database, I'm going to have three methods in principle. One of them is find all, which we've already seen. One of them is find one, which is going to find the first thing meeting the conditions. And one of them is going to be find by ID. And in this case, obviously, if I want a particular book, I have to supply the definition for that book. And I have a path parameter, right? And the path parameter is going to have some key here, and I will then be able to access it through request parameters. Right. So find by ID, request parameters ID, and I might get what I will get is some sort of result or an error. However, if I do something which is a select star from books where ID equals whatever ID I got, this is going to be validly run even if it gives me 0 rows, right? I'm only going to go on the catch branch when something happens which was not under the control of the user, right? It's not the fact that they supplied an ID which didn't correspond to a book, but rather something like I wasn't able to connect to the database, or I didn't have the right to select from that table, or that table didn't exist, or something like that. Well, but I have, in this particular case, I also have an error which is going to be application specific, which is I'm going to say to the user that if they requested a non-existing book, they get a 404 not found. The resource doesn't exist. The operation completed successfully. It's just that I didn't get a result which was what I expected. Now, by this logic is interesting because we can't edit or delete something which is not existent. Right? So we have to check that it exists first, and if it doesn't exist, we're going to give the user an error. So let's look at our edit. Now our edit is going to look like this. I'm going to find my book by ID, and when this is going to resolve, I'm going to have some sort of result. This result will either be a book or no. So if I get a book, I have to go to the next step. If I don't get a book, I have to send an error. I remind you that on any code path, I have to send something to the user. But on this code path, I can't send something to the user yet, because I have to do an additional operation, and the additional operation is going to be update. Update is going to take the content of my request body, in this case, key by key, and copy it in my entity on their respective keys, and then save it. Now, this one is also going to return a promise. If it returns a promise, I'm going to be able to chain it. So if this then resolves successfully, I'm either going to have sent something to the user and the communication has ended, or I've done something else which will return a promise. And in that case, I'm going to be able to enter this then and see if it resolves successfully. It resolves successfully if I manage to update the thing. If I manage to update the thing, I'm just going to notify the user that it was modified. Now, delete is going to function in a similar fashion. The only difference is going to be that instead of updating, I'm going to do entity.destroy, which is going to remove the entity. Now let's test this out first. Our API is still running. So let's get book number 1. Right, so it's our invalid book. What if we requested book number 10? Well, this one does not exist, so I get a not found. It's an application error, it's not a framework level error. So let's get this one again. And now let's try to change it. So we're going to say put at books/1. And the put is going to have to specify what I'm trying to put instead of it. So this is going to be modified. This does not support bulk operations because we didn't write it as such. So yeah, let's just write modified. Again, I have to have my header, which is going to be content type application JSON. So I've modified it. Let's see if it's now what it was supposed to be. And it's now what we wanted it to be. Now if I want to delete it, I can run delete on it. It's going to say remove. And if I then try to get it again, I'm going to get a 404. Make sense? So this is my somewhat the simplest API I'm going to be able to do, which is going to have persistence. Do you have any questions until now? Okay, so we have a couple more things we want to discuss. The first thing is going to be that we've done some queries, but our queries aren't really all that complex. Right? So let's look at some additional queries. Let's first close our service. One sec. Let's look at some additional queries. This is not an API. This is just a console application. And I see that I have the usual thing. I require Sequelize. I create my Sequelize object, which does not use timestamps. But I have something else, which is const op is Sequelize op. Okay, this is going to be relevant later. What I've done here is just basically created the simplest form. And I have some persons, and the persons have a name, an age, and a salary. And right now, after I sync, I'm just going to create 3 persons, right, which are John, Jim, and Jane. Then I'm going to have a series of operations. So let's for now, let's just comment these and see what's going to happen. In this case, I said person.findAll, and I used a configuration object which says a couple of things. First of all, it says where name John. This functions as a mask, so it's where name equals John. And then I said raw true. Now raw is actually going to return not those complex objects that I use to manipulate the data, but rather the simpler objects that I've already seen when I've used the service, right? The things which I've seen represented in the JSON. So objects which only contain the data value. Okay, so let's see if this works. Right, so it's general node queries. So it's inserting everything, and in the end, I get John, which is the only field which matches it. Okay, let's cascade this into something else. And now we're going to say person find all where name Jim and age 30. That's why I said the thing functions like a mask, right? Because I can look at it like this, and I'm going to get all the objects which match both of these things. Let's just see it too. So now, after I get John, I actually get Jim, which matches both things. Right? It matches both name and age. Now, what if I want to have more complex queries? Well, I'm going to have to use operators. And in the past, operators in Sequelize looked like something like that. There were specific operators which were strings, and they had something like greater than. But now they've been replaced with symbols. Now we've not managed to talk about symbols. So what are symbols? Now something we didn't see until now is the fact that we've used a lot of object keys, like name for example here. But the keys actually have a type, and their type was actually string. And in JavaScript 6, we've had another type of key introduced, which is a special one, which is called symbol. And the difference between a symbol and a regular key is that it guarantees global uniqueness. Right? So what I define by symbols are concepts. And in this case, is the concept of a particular operator. Right, so how would a query with a symbol look like? Well, the only difference is going to be that I'm going to write the symbol itself in a rather strange fashion, which is they're written like this, between square brackets. And I have a series of symbols predefined. And in this case, this is going to mean salary greater than 1,000. Make sense? Okay, let's just print the result. It's going to be a more complex one. Let's run this. We messed it up. That's because this is not what we were supposed to uncomment. It was this one. Okay, so I actually get salary greater than 1,000, and this matches both GM and J. And I can see, as an aside, I can easily cascade promises, which will allow me to do a series of asynchronous operations in order, as if they were synchronous. Now let's look at a more complex query. And my operators, if I'd want to know what my operators are, let's just look at them all. Right, so I'm going to have a list of operators in the documentation, and I see I have and, or, greater than, greater or equal, less than, lesser or equal, not equal, equal, not, etc. What I'd expect. But I also have some operators which the database itself might not support, right? Which are regex operators, for example, which are much more advanced thing than, for example, a like. Regex can be something more complex. Not that we're going to have one in our example, but it can. It can represent basically anything. So let's uncomment this and try to understand what's happening here. So I'm going to find all persons for which, where. Now I'm going to have a series of conditions in an OR. And this is going to function like this, or, and I'm going to have an array of things. So it's the first thing, or the second thing, or the third thing. My first condition is going to say salary, and these, if I just put them like this, these are going to function like an AND. So it's where salary greater than 1,000 and less than 2,500. And then age. I could have written this in a simplified fashion, so I can say age between 20 and 25. Or name matches a particular regex. And in this case, it means at least one character followed by an A, followed by at least one character. And this is actually only going to match J. So let's see this working. Right, so in the end, this one was actually matched by the first one, I think. This one by the second one, and this one by the third one. So I actually get all records. So I can build flexible queries, well, at least as flexible as I would have been able to build in SQL. And considering that I get these regardless of which relational database I use, I might get functionality which is superior to the database. Okay, so let's look again over this. Now I saw where, which allows for selection. I'm also going to be able to use attributes. And attributes, for example, if I would have said find all, person.find all, and I would have said attributes, and that would have just contained name. I would have just got objects which had just name. Just like in SQL, I would have been able to say select name from persons, right, and just gotten the name column. Now include, like I said, it forces eager loading, which means that I'm going to be able to include a child collection alongside a set of child entities alongside a parent entity. Now back to this idea of parent and child. One sec. Back to this idea of parent and child. I can define complex relationships in my Sequelize, which are going to be like this. So if I want to have a relation which is going to be a one-to-one thing, I'm going to be able to say, for example, author has one publisher, which may or may not be true. Now I can reflect this in this particular order, or I can say publisher belongs to author, one of both. The difference between has one and belongs to is the fact that I'm specifying who the source is differently. In this case, author has one publisher means that publisher is going to contain a foreign key to author. This is exactly what publisher belongs to author means, but had I said author belongs to publisher, I would have had the key to publisher in author. Now apart from this, I have has many, and if I say something like we already saw, we saw it somewhere here, I think, which is author has many messages. This means that message is going to contain messages is going to contain a foreign key to authors. And I can also represent many-to-many relationships. In this case, there's going to be a matching table, right? So it's a table which just matches IDs from one side and from the other side. And I'm going to need to say both author has many messages, and if a message can have more than one author, I'm going to say message belongs to many authors. This is non-directional in a sense because I have this table in the middle, which will have to be specified. Let's see if we can find an example. Right. Will have to be specified. So through something. And this is going to have a corresponding table. If you remember from databases how a many-to-many relationship would have been represented in the database. Right? Everybody has a key to a matching table. Okay, now let's go through some other stuff which we've already seen now, which is that we can actually do delete, obviously, by destroy. We can also actually do update. We can actually update stuff via the update method, which we've already done, or just get a method from the database, change its fields, and then do something like person.save. This is just going to persist whatever modifications we've made in memory. Okay. Now something else which must be taken into account is the fact that all that we've discussed until now is going to apply in the case in which we have a new application. Right? We can destroy the data model at any point and recreate it. But this is not going to be the most frequent case when we work in the real world, because we most likely will have to write an application on pre-existing data. And the pre-existing data can't be modified structurally. And I don't have that option. So what I'm going to need to do is adapt my models to pre-existent tables. So in order to do that, what I'm going to have to do and be able to do is specify table names manually and specify fields manually. So in order to specify table names manually, I can do like this. So Sequelize define entity, table name, whatever table name I previously had. Now, I was saying about convention over configuration, and this is one case where the convention doesn't suit me. And if the convention doesn't suit me, I can always opt to configure my application. If, however, like I said, I don't have to configure anything. So in this case, for this particular thing, so if I said Sequelize define user, table name users, this was pointless, right? Because the table name would have been users. For a particular field, for example, user ID, right? It's a type whatever, and it's field user ID, because it was pre-existent. again, for a key, I can actually define my primary key. If I define my primary key, Sequelize will not feel the need to create a different one. Like I said, a primary key is necessary in order to have the mechanism itself work. Do you have any questions until now? Did you understand? Okay. Now let's look at a more complex example, which is an API which handles two entities, which are a parent entity and a child entity, which is similar to what you have to do for your project. Now, difference here is going to be the fact that we have some advantage by reflecting the fact that the entities are dependent to the exterior, which means we're going to make some specific endpoints which will allow us to modify, to manipulate a chapter, for example, as being something dependent of a book. I could go on a different route and move all this complexity to the application level. So just have entities which are accessible and let the connection between the entities be handled on the application level. But in this particular case, I've opted to not do that. So let's see. First of all, we're going to have our operations on book. We're going to have our create endpoint, which is going to create my tables. Then we're going to have our operations on books, and this gives us a chance to look over them again. So this is going to be get books. It's going to be book.findAll. Right? It's going to give me all the books. A post on books is going to be book.create. They're the same methods as last time. We've eliminated though the more complex behavior, so it doesn't know how to bulk add anymore. Then we're going to get a particular book. For a particular book, we're going to find the book by ID. If the operation completes successfully, we're going to get something, but we're either going to get a book, and then we can send it to the user, or we're going to get something which is null. We're not going to get any particular book, and then we're going to tell the user that it was not found. So they can try again to request a different resource. For put, we're going to find the book by ID and update it based on what we received from the user in the request body. For delete, we're going to destroy the book. Right. And after this one, we're going to have the endpoints relating to chapters. Now let's look at our chapter definition again. So our chapter is again something which has a title and the content. The title is going to be Sequelize string. The content is going to be Sequelize text. And the book has many chapters. Now because the book has many chapters, I'm going to have a foreign key on chapter, which is going to refer to a book. Now, like I said, we like it to reflect this relationship between books and chapters. So we could get something like app.get from books a particular book, and from that book, the list of its chapters. And the way this is going to work is we're going to find the book, because we want to ensure that it's something valid. If the book exists, we're going to say result.getChapters. And this is interesting because, like I said, some methods were created at runtime. And although obviously we've not defined the getChapters on book, it's been defined by Sequelize. This is actually going to do my query, and I'm going to possibly get my result if I don't get an error. Now, if I want a particular chapter, right, I can actually, let's wrap this so it's better. Okay. I can actually say result.getChapters, and I can see that these added methods actually work like fine. So I can supply them with where. So I'm going to get the chapter which matches this thing, which is ID is request parameters CID. I can see then that I can have multiple path parameters, multiple request parameters, and I'm just going to differentiate between them via a particular name. So if I write them like this, this is going to be something which is called BID. This is going to be CID. And if I get my chapter, my particular chapter, I'm going to send it to the user. Now for post, what's going to happen is I'm going to find the book I'm trying to post. And what I have to handle here is the fact that the user has not provided me with the foreign key value in their request. right? They just probably they provided me with the chapter definition, so with the title and the content. So what I have to do is I'm going to find the book on which the chapter has to be added, and then I'm going to decorate what I got from the request body with a new thing, which is going to be book ID. And this is going to actually allow me to create a valid chapter. And after I manage to create it, I'm going to tell the user it's been created. So I have two more things which are put, and I've elected to treat put as something separate, right? This is how put would have looked even if we decided to treat chapters as separate entities. And delete, which is going to destroy something. Now I'm going to upload the source for this on my website, obviously, and I'm going to let you test it. Now there's a couple of more questions. What will happen if I delete a book? Will I delete the chapters? What might happen? Well, I have to handle something which is called cascading. Right? I have to specify somehow, or to treat somehow the idea of cascading, because I might want to decide if I delete a book and the book has chapters, I might want to not let you delete it. I'm definitely not going to want to delete the book and leave the chapters orphaned. So I'm either not going to want to let you delete it, or I'm going to have to handle the deletion. Right? So if I delete something, I'm going to delete everything which is dependent on it. So I can delete a book and its chapters in one fell swoop. What else? Obviously, like any kind of ORM, if I do have something low level, I can run native queries. Right? So if for some reason the ORM will not allow me to do what I was interested in doing, I'm going to be able to use raw native queries and write SQL. But this has to be avoided. So it's left to cases where I have no other solution. Okay. One sec. So the way cascades are going to work are like this. Right, so I have an association and I can configure it by saying on delete cascade. Right, and this is going to destroy my children along with my parents.